Good morning. So we will start. Let me please give me 1 minute. So we will be starting very soon. Okay, so let's start now. So this week, we were talking about the hardest logic puzzle ever, and also the introduction of predicate calculus. So again, you are all proceeding very well. So I don't receive any questions from you. So instead, this is something interesting I have prepared for you today. So these are, so I've just sent you the assignment one questions. So assignment one and also all the other assignments, they are for your practice uh, as a voluntary basis. So there is no need to submit it. Of course, you can discuss with your classmates, try to work out, and then if you have any problems or you want any hints, you can send us email. And then, so today's tutorial, I have selected some of the puzzle questions from this assignment. So if you want to think about it yourself, then I will first make the problem description, and then you just try to think about it yourself before reading the solution here. So here, let me start. So we have the first puzzle. Now in this puzzle, we are looking at some cards, and then each card is known to have some shapes drawn on the face. And then exactly for each card, there will be one face with a solid shape and one face with an empty shape. So for instance, this is card 1. So on this side, it is showing a solid circle. So at the back of this card, it must be some empty shape. I don't know what it is, but it must be empty something. And similarly, the second card here, we have a empty shape, an empty square here. So we know that for sure that at the back of this card, it must be a solid shape. Is that okay? Now this is what is known. But then your friend Peter says, okay, Peter says something extra. He says that the opposite face of a solid circle is an empty triangle. Now, this is something that you do not know. It may be correct, it may be wrong, but this is from Peter. Peter says solid circle, then the other side must be an empty triangle. Somehow, you don't believe Peter. So, in order to convince yourself that Peter is wrong, then you are allowed to turn some cards over and see what is the back of, so what is the face on the back of the card. So what is the minimum number of cards to turn? So this is the first question. Okay, so I call it puzzle one. And yeah, you need to give reasoning why it is correct, why it is minimum as well. Okay, now the second one. Now the second puzzle is this one. So we have a mathematical expression for long division. Somehow we have the digits, they are marked, they are missing. Okay, so they are represented by a star shape. And then there is a number y here. Y is a certain positive integer. So y may not be a single digit. So y is some positive integer. So here for this long division formula that we have, we want you to find out what is the value of y and what are the missing values in this formula. Okay, so you need to fill them out. And then the third one, okay, the third one is a very famous puzzle. So in this puzzle, it is again another mathematical expression. So this time, it is representing addition. So we have each of the character here represents a single digit, and then the character here, they are all distinct digits. So each distinct character represents a distinct digit. So the two M's here means they are the same digits. The two O's here, that means they are the same digits. So you have E's here, so they are all the same digits. But then the S, the M, the O, the N, the E, the R, the Y, the D, they are all distinct digits. So here we want you to decode. So what is actually the digits for each character? Okay, so these are the description of the three puzzles for today. And then, yeah, if you want to think about it, yeah, so you pause it and then, or you revisit this OCW, this YouTube live recording later. But if you want to think along with me together or look at the solution, yeah, you can continue now. Okay, so here, this is puzzle number 1. So let us recall, okay, so the first one is a fact. So this is always true. So each card, it must have one solid and one empty on the faces, okay? And then what you want to verify or what you want to disprove is whether Peter's claim is correct. So Peter says solid circle must have empty triangle on the opposite face. So let us check one by one whether each of these cards should be turned or not. You don't want to miss out any chance of disproving Peter, but on the other hand, you don't want to turn a card which is not important. So let us take a look of the first card. Shall we turn it over or not? Now for the first card, it is a solid circle. Now, this card should be turned because if the opposite side of this card is not an empty triangle, it is empty something, let's say empty circle, whatever, then you can immediately disprove Peter. Yeah, because Peter says solid circle must have empty triangle on the other face. So you should turn over this one and then see that whether this is really an empty triangle or not. So card 1 should be turned over and you don't want to miss it. Okay, if you do not turn it and let's say this one is the only proof that Peter is wrong, then you will regret. So in that case, you must turn card 1. Okay. Now how about the second card? Now the second card is an empty square. Then in fact, you should also turn card number 2. It is because the opposite of this card is a solid shape. It could well be a solid circle. If it is the case, if the opposite of 2 is a solid circle, you can also disprove Peter immediately, right? So card 2 should be turned because you don't want to miss a chance of disproving Peter. How about card 3? So card 3 is an empty triangle. Now this is something interesting. Now of course, the opposite side of card 3 could be a solid circle, it could be a solid other shape. But whether it is a solid circle or a solid square, let's say, then turning over card 3 doesn't help you in disproving Peter. Because if it is a solid circle, you just say Peter, oh, is correct for this particular case. And if it is not a solid circle, let's say it is a solid square, then in that case, it is irrelevant about Peter's claim. So turning card 3 over does not help you in any sense in disproving Peter. So in that case, card 3 is not important. So you should not be turning card 3. And how about card 4? So card 4 is a solid triangle. So you know that on the other side, it will not be a solid shape. So no matter what happens, so card 4 is irrelevant to Peter's claim because it is not talking about solid circle. The opposite of it is what? Yeah, because it is already a solid triangle. The opposite side could not be a solid circle, right? And then whether it is an empty triangle or not, it doesn't matter to Peter's claim. So in that case, card 4 should not be turned over. So in summary, for this particular puzzle, the minimum number of cards that you want to turn is 2, and they are card 1 and card 2. Okay, so this is puzzle number 1. Okay, now let's take a look of puzzle number 2. Now, assume that you have already spent enough time analyzing this puzzle. So this puzzle has a lot of information. Although it is just showing two digits, 8 and 0, but it also has a lot of information that we can make use of. So for instance, we can see that y, when it is multiplied with 8, so this gives us a two-digit number. So that means that y times 8 will give us a two-digit number here. Now, on the other hand, y times some single digit will give us a three-digit number. Now, if y times 8 only gives us a two-digit number, then we must have this one has to be larger than 8. Otherwise, it is only two-digit, right? Or fewer than two digits. So the only possible digit that is larger than 8 must be 9. So this is going to be the 9 here. So here it means that y, when it is multiplied with 9, we will get a three-digit number. So this number has to be 9. And then we know that 9 times y will have three digits. And then the other case is that, okay, now let us imagine what kind of number when it is multiplied with 8 has two digits, but when it is multiplied with 9, it will have three digits. So we can actually try all the possible cases, and then there's only one case. So y cannot be too small. If y is smaller than 11, smaller than or equal to 11, then 9 times y cannot have three digits. On the other hand, when y is larger than 13, then 8 times y will not have two digits. So in that case, the only possible value for y is 12. There is no way out. Y, there is only one option. It must be 12. Now, once knowing that y is 12, then the other part will be very, very easy. Okay, now y is 12, and then we know that in this quotient, okay, after the long division, the first digit has to be 9 because 9 times y will now give a three-digit number. And similarly, the last digit in this quotient will also tell us that it is giving a three-digit number. So this has to be 9 as well. So y is 12, the first digit is 9, the last digit is also 9. So 9 times 12 is 108. So we know that this is 108. So 108. And because there is nothing here, so the first three digits in the dividend here is 108. And because we don't have anything here, so this must be a 0. And then these two numbers is 96 because y is 12. 12 times 8 is 96. And similarly, this is 108, 108. So after we complete all the missing digits here, we will find that this has to be 97 because 97 minus 96, you get a 1 here, 108. So in that sense, we can fill out all the missing digits. So the original number is 108, 9708, and when it is divided by 12, we get 90809. Okay, so this is the solution of the second puzzle. Okay, next we are about to talk about the third one. Okay, so the third one here is, so we assume it is a normal case of doing the long addition. Okay, so we are doing addition in this format, so that the value of m is not equal to 0. Okay, so the value of m is not equal to 0, and then you have two four-digit number, and then when they add up, and then it becomes a five-digit number. So the only possible case for m has to be 1. And what is the reason? Yeah, because the largest possible value here is 9999. Largest possible value is 9999. So when they add up together, the sum has to be strictly less than 20,000. So the value of m cannot be more than 2, and it is not 0. So in that case, m has to be 1. Is that okay? Now, because m is 1, okay, and then we sum up two digits here, and then we get a O here, which is not equal to 1. So in that case, the possible value, the only Is it? Yeah, because m is now 1. Okay, so we also see that s times s plus 1, you get mo here, right? So s plus m will have a carry somehow. So the value of s could be equal to 8, or the value of s could be equal to 9, no matter what case, because there may be some carry over from the previous part. But in any sense, s plus m could either be 10 or 11 here. And then in that case, because this is an O, this is not an M, so the value of O has to be equal to 0. Okay? Okay, we are getting two values now. M is 1, O is 0. And now the next one is, we will see this column. We see that E plus O is 0, right? Yeah, this is something nice. O is 0, so yeah, it looks like a 0. Okay. E plus O, it is not equal to itself. And then anything, also another observation is, if you have anything, if you add to 0, you can't get a carry. Okay, the only possible way that you can get a carry is when you have E plus O is E is equal to 9 and you have an O, so that after you add up, you get 10, but that 10 will be having O here instead of N, so it is not an O here. So E cannot be equal to 9, or E cannot be adding up O to get a carry. So in that sense, there is no carry, and we must have S plus 1 is equal to 1, 0. No carry. So the only possible choice for S is equal to 9. Is that okay? So we are getting one more character. And now let's get back here again. So E plus O is not equal to E. So in that sense, O is 0, right? So E plus O is getting some different number. So it means that M plus R will give us a carry. So M plus R will be greater than or equal to 10. Or will be, yeah, or maybe 9. I don't know. Yeah, but there is a carry. But in any sense, in that case, we have established a relationship between E and N. So N must be exactly 1 more than E. Okay? So N is equal to E plus 1. Okay? And now, actually, this is something that we can do extra. So N plus R will give us a carry. Okay, N plus R will be ending with E. So there are actually two options for N plus R. So N plus R could be equal to 9 plus E when there is a carry from D plus E, or N plus R could be equal to 10 plus E. Okay, but if you combine the relationship of M is equal to E plus 1, so we plug, this is E plus 1, so E plus 1 plus R is equal to 9 plus E or 10 plus E, then we will either have R is equal to 8 or R is equal to 9. But then R cannot be equal to 9 because S is equal to 9 already. So we must have R is equal to 8. So in that case, R is equal to 8, and then M plus R is equal to E. So in that case, D plus V will have a carry. Okay. Yeah, because we are assuming this case. Is that okay? D plus E gives a carry. D and E add up, and then it gives us a carry. But then we know that M is 1. So 1 is already used, so Y cannot be 1. And so that means that D plus E has to be greater than or equal to 12. Okay, so we have gathered many information now, so it is already enough for us to try out all the possible cases where D, E, Y, and R can satisfy the equation. So now, so we recall that there are relationship between E and N. E is equal to N minus 1, or E plus 1 is equal to N. So En could be 2, 3, 3, 4, 4, 5, 5, 6, or 6, 7. We don't have the other cases because you can't use 0, 1, 9, 8 anymore. So these are all the cases that we can have. But we will see that when E is 2, 3, or 4, these cases, E is 2, 3, or 4, then they should be rejected because the value of E is too small so that they cannot make D plus E greater than or equal to 12. Okay? Yeah, recall that the value of D cannot be more than 7 now because there's R and S which is equal to 8 and 9. So D can be at most 7. So 7 plus all these numbers cannot be greater than or equal to 12. So they are rejected. And then the other case. So En could be 5, 6. So if E is equal to 5, this is equal to 5, then 5 plus something is at least equal to 12, but then you have already used up R is equal to 8 and S is equal to 9. So when E is 5, we must have D to be 7. And when D is equal to 7, Y has to be 2. And then after that, you can fill out the cases, and then you will see that it will give us a certain answer. On the other hand, how about the other case? When E is 6, N is 7, then this is 6. But then we need 6 plus something to be greater than or equal to 12. Now 7 is used up for N now for this particular case. So there is no D that we can use so that it can make D plus E is greater than or equal to 12. So in that case, it is also rejected. So in summary, what do we have? In summary, the only possible case for En that can satisfy this puzzle must be E is equal to 5, N is equal to 6, and then D is equal to 7, and then Y is equal to 2. So in that case, this is the answer for this particular puzzle. Okay? Yeah, you can check it one by one. Now, here we say that we are talking about the normal case, M is equal to 0. But then the original description of this puzzle doesn't say that M has to be non-zero. So there could be a case where M is equal to 0. I think you can also try this out and then convince yourself that there will be exactly one more solution for this case. So when M is equal to 0, there is exactly one solution. Yeah, you can try it out for yourself later. Okay, so that's all for the tutorial for today. Yeah, and then I will send out soon what is the suggested progress for this week. Okay, yeah, thanks a lot. Okay, see you on Wednesday. Thank you. For the assignment of assignment 1, we won't. Yeah, they are easy questions, so you can work it out by yourself. And if you encounter any difficulties, just send us questions. Okay, thank you a lot. Okay, see you.